Hi everyone, I am Dr. Suman, Assistant Professor from School of Basic and Applied Sciences, Maharaja Agastyan University. Today I am here with the topic Basic Logical Operations, which is the important part of mathematical logic from discrete mathematics. So here we have three basic logical operators which are conjunctions, disjunctions and negations, which correspond to respectively and, or and not. This and stands for conjunction, or stands for disjunction and not stands for negation. So let us discuss one by one all the three basic logical operators. So first of all, see the definition for conjunctions. Here I am taking two statements or sentences. So let P and Q be the two sentences. We say that the sentence P and Q, the symbol between the P and Q stands for and stands for conjunction also. So is true if the statements, two sentences P and Q both are true, and is false otherwise. So let us see the two examples. In example number 1, here again two sentences we have. In sentence number 1, 3 plus 3 is equal to 6, which is a true, and 3 plus 4 is equal to 7, which is also true. In example number 2, the sentence 3 plus 3 is equal to 6 is true, but in the second sentence 9 plus 2 is equal to 10, which is a false. So how we can take these two sentences in the truth table using the conjunction? So observing that in giving the truth table of P and Q, we need to look at 4 possible cases. This follows from the fact that each of P and Q can be true or false. So if we use the letter T denotes the true and the letter F to denotes false, so then how we can use these definitions in a truth table? So let's see the truth table for the conjunctions. That is, here we have two statements P and Q. So 4 possible cases we have. In row number 1, when the statement P is true and Q is true, then its conjunction is also true. In row number 2, when the statement P is true and Q is false, then its conjunction is also false. Then if the statement P is false, Q is true, then its conjunction is false. Then both the statements we can see in the row number 4, if both the statements are false, then its conjunction will be false. So this is the truth table for the conjunction. So for example, consider the two statement, he is a practical, he is a sensitive. Then how we can take its conjunction? Its conjunction is he is a practical and sensitive, and is a conjunction here. So the conjunction will be true when both the statements will be true, and the false even is one of the component is false. So we can see in the truth table, when one of the component is false, then its conjunction for the statement is also false. Now let us see some more small examples based on it. So here again I am taking two statements. In example number 1, P is a statement 5 plus 7 is equal to 12 and Q is 2 is a prime number. Now take its conjunction. How we can take its conjunction? P and Q. 5 plus 7 is equal to 12 and 2 is a prime number. Okay, now P is a true and Q is also true, and its conjunction is also true here because both the statements are true here. Now in the second statement, P is every even number is divisible by 2 and Q 12 is an odd number. So how we can take its conjunction now? P and Q, every even number is divisible by 2 and 12 is an odd number. Now we can see here statement P is a true but Q is false, and its conjunctions will be false here. Again, next we have the next logical operator, that is disjunctions. So again let P and Q be the two sentences. We say that the sentences P or Q, the symbol between P and Q stands for disjunctions looking like a B. So is it true if at least one of the two sentences P, Q is true and is false otherwise. Again we have some examples. In example number 1, the sentence 1, 3 plus 3 is equal to 8 and 2 plus 3 is equal to 6, which is a false. Second statement, the sentence 3 plus 3 is equal to 6 or 2 is an even number, which is true. Okay, again how we can take, again we have 4 possible cases. Let us see in the truth table for the disjunction P or Q. So again we have two statements P and Q. So in a first column we have a P statements, in a second column we have a Q statements, and in the third column we have a P or Q. So if first statement is true, second statement is true, and its disjunction is also true. When second statement is true, first statement is true, second is false, then its disjunction is also true. Then if P is false, means first statement is false, Q is true, means second statement is true, then its disjunction is true. Then both the statements are false, then its disjunction is false. So this is the truth table for P and Q. By using these truth values for these conditions for the disjunction, we can easily solve the examples. So now again see this example. For example, consider the two statements P and Q. P, there is something wrong with the teacher, or Q is the statement, there is something wrong with the students. Now how we can take its disjunction? There is something wrong with the teacher or with the student. So this or is inclusive or, that is there may be something wrong either with the teacher or with the student or with the both. So let us see again some simple examples. Again I am taking example number 1. Two statements we have. P is equal to 5 less than 12 and Q is 8 plus 3 which is equal to 12. So therefore how we can take its disjunction P or Q? 5 less than 12 or 8 plus 3 is equal to 12. Again we can see here P is a true and Q is false. Therefore this conjunction is true because one of the statement is false and one of the is true. So when P is a true, Q is false, then its disjunction will be true. So second example, again two statements we have. P statement, every even integer is prime, and Q is 5 less than 3. So how we can take its disjunction? Every even integer is prime or 5 less than 3. Here P is a false and statement Q is also false. Then its disjunction will be also false because both the statements are false here. Okay, again a very simple example with the two statements. P is 3 plus 5 is equal to 8 and Q is 1 plus 6 is equal to 9. Okay, so here P is a true and Q is a false and their disjunction is true. Next logical operator we have negation. So let P be a sentence. We say that the sentence negation P, the symbols with the P stands for negation here. We can pronounce it as not P. So is it true if the sentence P is false, and is false if the sentence is P is true. For example, I am taking example, the negation of the sentence Taj is in Delhi. So is the sentence, and how we can take its negation? Taj is not in Delhi. Just we have to write the not for the negation. So truth value, see the truth value for the negation. So here P is a statement here. So if the statement is true, then its negation will be false. We can see in the column number 2. When statement P is false, then its negation will be true. Okay, thus the truth value of the negation of P is always the opposite of the truth value of P. Okay, so some points we have to remember. To every statement, every sentence, there correspond to statements which is its negation. So negation refers to the contradiction, not a contrary statement. So we should be very careful while writing the negation to the given statement. So the best way is to put the word not at the proper place. It is not the case that in the beginning. Okay, so for example, if P stands for, if P is a statement, he is a good student, so negation of P will be P is not a good student, or we can take it as it is not a case that he is a good student. We cannot say that he is a bad student. Means we have to write just a not for the negation statement. There is no need to change the word. We have to just write the not for the negation for the statement. Now these are about the basic logical operators, that is conjunction, disjunction and negations. Now we have tautologies and contradictions. Again, a tautology is a sentence which is a true on logical ground only. Let us try with the help of try to understand with the help of an example. So truth table, if a statement P we have true and the statement second statement will be false. So how we can take its negation? So negation for the statement true is false and negation for the statement of which is false is true. So let us take its or. So negation, this conjunction for the two statements, when P is a true, Q is a false, then the disjunction will be true. When the statement P is a false, negation of P is a true, then again its disjunction will be true. Now we can see here in the third column all the values is true. So this is the tautology we have, because in the third column T is the true tautology. So a contradiction is a sentence which is a false on logical ground only. For example, the sentence P and negation of P is a contradiction. So let us try to understand with the help of an example. So let us take a statement P which is a true in a first row. When it take its negation which is a false. Okay, negation of true is false, and take its conjunction P and negation of P is false. Then in the second row statement P is false and its negation is true. So when first statement is false, second statement is true, then its conjunction will be false. So that is about the tautologies and contradictions. Now next we have another statements, that is a conditional statement. So we say that the sentence P implies Q. So this symbol between P and Q stands for implies, or we can say that if P then Q is true, if the sentence P is false, or if the sentence Q is true or both and is false otherwise. We can say that sentence P is a true and the sentence Q is false, then the statement will be false. Then the conditional statement P implies Q will be false. The statement P is called the hypothesis and the statement Q is called the conclusion. So here the connective if then is denoted by the symbol this implies, looking like an arrow. So the condition P implies Q is frequently read as P implies Q, P only if Q, and the truth values of P implies Q is shown here. So see the truth table for the conditional statement. Again we have 4 possible cases. In a column number 1, we have a P statement. In column number 2, we have a Q statements, and we will take its condition. P implies Q. So in the first row, see here, statement P is a true, statement Q is a true, and its implication is also true. In a second row, statement P is a true, statement second is false, then the P implies Q is false, because first statement is true and second is false here. But in the condition statement, we have to take the truth value true for if P is a false and Q is true. So in the third row, we can see here, if P is a false, Q is a true, then P implies Q is true. When both the statements are false, we can see in the fourth row, P is false, Q is also false, then the truth value is true. When both are true, then true. When both are false, then false. When first statement is false, second is true, then we will take true. But if first statement is true, second is false, then we will take false. So this is the condition for the conditional statements. Next we have a converse, inverse and contrapositive of the statements. So if we have again 2 statements, P implies Q, we know that is a conditional statement. So if we take Q implies P, so it's called its converse. Negation P implies negation of Q is called its inverse, and negation Q implies negation of P is called its contrapositive. Again, with the help of truth table, we can discuss 4 possible conditions. Now we know that what are the conditions for the conditional statement. Now according to the condition, we can assign the truth table for the converse, inverse and contrapositive of a statement. Let us see the example. Let P is a vowel and Q is the statement 1 plus 2 is equal to 2. So how we can take P implies Q? If A is a vowel, then 1 plus 2 is equal to 2. Now P is a true and Q is a true. Okay, so therefore P implies Q is also true. Okay, because statement first is true and second is also true. Both are true here. Okay, now the conditional statement next we say that the sentence P if and only if Q is true if the 2 sentences, means both the sentences are both the true or both the false. But if this case will not happen in an example, then we will take directly false for that. So that P if and only if Q can also be stated as P is necessary and sufficient condition for Q. So how we can let us try to understand with the help of an truth table. So here again in the first column we have a P statements, in column number 2 we have a Q statements. We have to take P if and only if Q. So again we have 4 possible cases. In statement number 1 we have a true. In statement number 2 again we have a true. So P if and only if Q is true also. But when both are true, then true. When both are false, then the truth table for P if and only if is true. But if one of them is false, then we will take the false for the biconditional statements. This is the theorem. Based on this, we have to show that P implies Q is equivalent to negation of P or negation of Q. Now we should know the conditions for the conditional or and disjunction and conjunction statements. Again we have 4 possible cases. In P statements we have 4 case. In Q statement we have 4 case. When both the statements are true, its negation will be P is a true, false, true, false. How we can take its negation? Negation of P. When P is a true, negation of Q is false. When negation of Q is false, then if P is a true. Okay, now P implies Q. Again, using the condition, we can take only for the case if first statement is false, second is true, then we can take it's true, both are true, then we will take true, both are false, then we will take false. And find the negation P or Q using the condition for the conjunction. So again, comparison of the last two columns, the truth table show that they are identical, and we can show here P implies Q is equivalent to negation of P or Q. So that's it about this theorem. Second, we have a negation P implies Q is equal to P and negation of Q. Again, we have a 4 possible cases and know the conditions for negation and conditional statements. Again, for the 4 possible cases, when both the statements are true, both are false, one of them is true, using the conditions for negation and conditional statements. We can see here a comparison table of last 2 columns in the truth table show that they are identical. So we can show here the negation P implies Q is equal to is equal to P and negation of Q. So that's it about the basic logical operators, disjunction, conjunctions and negations, and some more important statements, that is tautologies, contradictions, conditional statements. Thank you.